Hi there students, this is Dr. John, your physics and math professor, and in this video I want to cover all the different types of graphing you're going to need in high school. Often we're very confused because there's so many different things to graph. Well, I want to go through all of those systematically. Here's all the different things that I want to go through. I'm going to do them rather quickly. So first of all, I'm going to talk about points. Let's say you want to put points on an XY graph. So here we make an axis with the X and we'll draw the points, just like you did in the lower grades, 1, 2, 3, 4, and then this is the 0 and it's minus. And then you draw another axis at 90 degrees that's called the y-axis. This is alphabetical. X, Y would be alphabetical. This axis here is called the independent variable because usually that's the one you can just pick independent. You can say, well, I want X to be 4 or whatever. But once you've picked the X point, the independent variable, that's going to automatically determine your dependent variable. So the y-axis is called your dependent variable. So I've graphed a couple of points for you here. Let's say I wanted to graph the point 2, 3. Just I've labeled it here. What you do is you go over in the X, you go over 1, 2, and then you'll draw a dashed line up and down, like I did there, and then you'll say, okay, that is the first point, that's the X point, and then for the Y point, the second one, so this is the X point, the second one is the Y point, I'll go up by 3, and then I'll make a dashed line across like this. Where those two meet is my point, 2, 3. I'll write that point in there. I'll do the same for minus 4, 1. Go over minus 4, go up 1. So in this case, I'm going negative this way, the X is negative, the Y is up. I'll put those points in there. Now what I've done also here is, let's say I have these points, I've drawn these points, but I want the inverse. The inverse is going to become in very handy in the future in a number of these other things that I'm going to explain to you. What you do to get the inverse is you just switch the points. So instead of 2, 3, you're going to say 3, 2. Just switch them around. Make the X into the Y and the Y into the X. So I've plotted those here in the red. 3, 2 for this one, and 1 minus 4. Now notice here if I drew a line, this light green line at 45 degrees here, halfway between the X and the Y like this. If that is like a mirror, then notice that this point 2, 3 sort of gets reflected right over here. Those are like a reflection of each other. And these points also are like a reflection of each other over those lines. And that's called the inverses. Second on our list is we're going to look at lines. Straight line is the very simplest thing you can do. A straight line like this here, any 2 points. If you draw just 2 points, you get a straight line. Now notice here that this straight line has a slope. This is one slope, this is a higher slope. How do you calculate the slope? The slope, often called m, little m, is the rise over the run. So you go from one point to the next. How much does it go up? Remember, you can just connect this with little dashed lines like that. How much does it go up? In this case, it goes up 2. In this case, it runs this way. So you normally run on a flat surface and you climb up, so the rise over the run. So it's 2 over 1 or 2. So the slope of this line is 2. The slope of this line would be less than 2. 45 degrees. If it goes at 45 degrees, the rise would be the same as the run, and the slope would be 1. Anything less than that is less than 1. If it's going down like this, a line, it would be a negative slope. So here we have this, and we want to calculate the slope. A way to calculate the slope is to take how much the y changes. So what is the change in the y? In other words, what's the rise from here to here? The change in the y would be y2, whichever, you can label this one 0.2 or this one 0.2. It doesn't matter. You'll get the same answer. You'll get like a double negative, or the negative will take care of itself. So in this case, this will be called 0.2. I just made it a little bit harder. So 0.2, the y value changes to this, and the x value, which is the run, changes from this to this. So notice here I've taken minus 2, that's the y value, minus this one here, and then minus 4, that's the x value, minus this one. If I did it the other way around, I'd get positive numbers on both of these, but I would still get 4 over 5, because this is becoming 4 over 5. The two negative signs will cancel, and we have a slope of 4 over 5. Notice that's just less than 1. This is less than 1. I said 45 degrees is 1. It's just a little less than that. The way that we like to label straight lines is something called the slope-intercept form, and that's any y value is equal to the slope times x plus b. Now, m, we already talked about. M is the slope. You calculate it this way. B is where the line runs into the y-axis, also called the y-intercept. And one more thing that I just wanted to mention here is if you have two lines that are perpendicular, let's say you have a line like this and you have a line like this that run into each other at 90 degrees, you'll notice that the slope of the one will be negative and the slope of the other will be positive. However you have them, one will be negative and one will be positive. If this one has a big slope, this one will have a small slope. So just think of this one over here. What if we had a slope that was 90 degrees here to this? Notice that the run would be 2, the rise would be minus 1, so the slope that in that case would be minus 1/2. So anytime you have a perpendicular line, the slope is the same slope as before, but flipped. It's inverted, it's upside down, and it's negative. So that would be minus 1/2. for this perpendicular line here. So that's all that I'm going to do here for straight lines. Next, I'm going to talk about domains and functions. A domain is all the values of x that you're going to need to graph this, and the range is all the values of y. If you have trouble remembering which order this is also alphabetical order. Just like x and y axis are alphabetical order, the domain and the range are also in alphabetical order. So in this case, the domain here would be, you would need everything from -3 to +3. Here the domain is all real numbers, but the range, of course, is you just need y being greater than 0. So you would write it like this. You would write x is an element of all real numbers. That would be for this one here. And y is an element of all real numbers such that y is greater than or equal to -1. So that would be for this one. Each of these, of course, would be different. This one, the domain is all real numbers, and the range is from -1 to +1. And this one, the domain is x has to be greater than or equal to 0, and y is greater than or equal to 0 as well. So that's a basic domain and range. So now we'll jump into functions. Now there's two different ways of describing these, a function and a relation. A relation just means the x and the y values are tied together in some way. And in each cases here, the x and the y values are tied together, but these are not all functions. A function means this, that if you give me an x, I can give you a specific y. So for example, in this case here, if I give you the x of 2 here, the y value is -1. If I give you the x value of 0, the y value is 0. It's all completely determined. If here I give you the x value of -1, there is no y value. So it's also completely determined. That's a function. There's another way of doing a function. It's called the vertical line test. And that is if you can draw a vertical line straight up and down, and it only touches the x, only touches the graph once, like here it only touches the graph there, then it's a function. So in this case here, this is actually the equation of a circle. Notice it touches it twice, so it's not a function, which means if I give you that value of x, there's two possible values of y, so y is not the dependent variable anymore, and it's not a function. So now we'll look at quadratics. I've got a couple of things to cover. First of all, the basic form. This is the basic form of a quadratic. Y is equal to x squared. Just plug in a couple of values if you forget what it looks like. 0 right there, 1, 1, -1, 1, and then 2, 4. So it goes straight up like that. So it goes up very high, very quickly. And then here is a modified version. Notice this is still a quadratic because it's still squared, but there's things that happen to it. And what I did here is I pulled it apart. I took these round brackets, replace them with square brackets. Everything inside the function here, I modified it so that it's a number and then x plus or minus something. This is the way that we like to do it because now we can see the different SRT operations on it. So this here, because it's inside the function, it's going to act on the x, and we're going to do the inverse of it. So in this case, it's a stretch of 1/3, a translation of 1 to the right, and these on the outside act on the y. It's a stretch of 2 and a translation of 1 to the right. Next, I'm going to show you 3 different forms whereby you can write a quadratic. So I've written it in 3 different forms. This is called the factored form, because with this one, you realize if you make this equal to 0, like this, then you realize x equals 1 and x equals -3 are going to be your factors. Those are going to be the places where it hits the x-axis, also called the roots as well. So those would be those 2 points. Those are obvious inside of here. In the standard form, that's the form where we would have ax squared plus bx plus c. And here's your A, here's your B, here's your C. This doesn't give us any real information about it, but what this does do is it allows us to use the quadratic formula, which I'll just remind you of in a second. This one here is the vertex form, which what that does is if you move to the left here by 1 and then go down by 4, so that's to the left by 1 and down by 4, this gives you the vertex here. So each of these, you can move between these 3 different forms. This one is hard to find information, but it's nice for the quadratic formula. This one, it's easy to find the roots, and this one, it's easy to find the vertex. So let me just erase this part here, and I'll do the quadratic formula for this one in a second. So the quadratic formula, minus b plus or minus the square root of b squared minus 4ac. This is a, the number 1, b is 2, c is -3. You plug those in here. What's really important is this thing inside the bracket, inside the root, which is called the determinant. So in this case, it's 4 minus this. Here's a double negative. So that's going to end up being 16. The square root of 16 is 4. If this value inside here, inside the determinant, is greater than 0, so if this determinant here is greater than 0, you're going to have 2 roots. It's going to hit the axis twice. If that determinant is only equal to 0, you're only going to hit the axis once. So you're going to have something like this where it's just going to hit once and then go off. If this is a negative number, it never hits the axis. It's it might be something like this where it never hits the x-axis. So here I've done this. Here I've found it's -1 plus or -2. So notice -1 actually of the quadratic formula, which is this part here, actually is the x-axis of symmetry right here, which you also found when you did the vector, the vertex form. And then plus or -2 is you go 1, 2 this way and 1, 2 this way for those two roots. So that's either way of the axis of symmetry. So I hope that helps with quadratics. Next, we're going to look at roots. So here now we have a square root function, which is the next thing I wanted to talk about. Remember the square function? We just talked about that. That's the purple one here. The square root function is the inverse of that. It sort of undoes the square function. Because if you have a square root here, if you have a square here and you want to undo it, you take the square root. That undoes the square function. So what I did is I drew a mirror at 45 degrees. I took this purple line and I just sort of reflected in that mirror. So that would be the square root function. Or if you want to simply plot a few points, use 0. That gives you 0. 1 gives you 1. 4 gives you 2. And you can't put any negative numbers inside there. So you just have this yellow line like this. Now how do we do this if we think of the inverse? Well, the original function here is y is equal to x squared. Let's exchange the x and the y. And now it's going to be x is equal to y squared. Now if I want y equals something, I take the square root of both sides. Y is equal to plus or minus the square root of x. This here would be square root of x, the negative square root of x, and this is the positive square root of x. Normally we just draw that part over there. Now let me do a quick review of SRT. I remember it by sort, SRT, because that's the order. This is sort of like BEDMAS. This is the order you need to do them. Stretch, reflect, and translate. If you're using my mathematical method, you can do your stretch and your reflection at the same time. So let me give you a practical example here. Here's a function, the square root of x, and a couple of points. 0, 0 would be right there. 1, 1 would be right there. 4, 2 would be somewhere over there. So here I'm going to take these points, and here's the equation that we're going to do to change it. So this looks like a really complicated, crazy equation. What we do first of all is we take the part inside the function. Remember the function here is just simply square root of x. So that's the main thing we're concerned about. I made big square brackets for the function. I took out a minus x, so it's just simply x plus or minus something. Minus 1/2, just like this, all squared, or all square rooted here. Now notice here, what's inside the function operates on the x, and we do the inverse of it. We do the inverse because we could take these things here and move them over here with the y, and we'd have the same format. But because we like to write the equation like this, the things aren't on the y side, they're on the other side over here. So these things inside the function operate directly on the x, and we do the inverse. So instead of minus 1/2, we do a stretch of -2. We keep the minus sign. We'll do the stretch and the reflection at the same time, because you could think of this is a stretch in the x, but this is a negative stretch of 2. So it's a reflection over the y-axis. And then we do a translate of 1 to the right, because it's the inverse of this. And then these here apply to the y, and we do exactly what there is, -2, and we do a translate of 2. So here I've sort of written it out with these 4 points. The x value, I'm going to be multiplying by -2, adding 1. The y value, I'm multiplying by -2 and adding 2. So I take these points, 1, 0, add 1 is 1, 0 for over here, times -2 is 0, add 2, and I get 2. So I do this for each of these points. Now I would graph these points. This is 1, 2, this is -1, 0. I would graph these points, and that would be my new translated SRT, stretched, reflect, and translated square root function. I hope that helps with SRT. Let's go on to the next thing, which is looking at polynomials. And polynomials can be any power. So for example here, a straight line, which is just y is equal to 5x plus 3, or whatever that is also a polynomial. And that's just, it goes to infinity as we go positive, it goes to negative infinity as this. But once we would have something like x squared, 5x squared plus 3x, whatever, if the highest power is x squared, then what that's going to do is it's going to take the negative, because it's going to make the negative also very positive. It's going to bend it in that direction. So we're going to have this going to positive infinity, that going to positive infinity. So anytime you have a quadratic, it's going to go up to positive infinity this way, or if the number in front of there is negative, it's going to go, of course, it's going to be reflected this way, and it's going to be going down this way. So that's a quadratic. If we have a third power, then what would happen is we would have x cubed, 3x cubed plus something else. The third power would dominate. It would still go to infinity this way. But when x is negative, it's going to go to negative infinity. So it's going to do something like this, and it's going to wobble like this. So it's going to wobble. This one here This one here can hit the x-axis once and only once, unless it's a line like this. It's a straight up line that has zero slope, then it may hit the axis 0 times, but otherwise it'll always hit it once. This one can hit it up to 2 times, or maybe just once, or never in this case here. This one here, if this was a little higher, if it was like this, it would hit the x-axis 3 times. It could hit it up to 3 times, and it would tend to go to, assuming that number is positive, to positive infinity and negative infinity. If we have something to the 4th power, it's going to tend to do something like this. It'll go to infinity again. Just think of, if you have trouble remembering it, just think of what the quadratic does, and then go to the 3 with the 3 possible roots going to infinity. This one, of course, is positive in both directions, so it's going to go to plus infinity. It could have up to 4 roots. If you have something like this, I just wrote this one out here, which is in factored form. It's really nice to have this in factored form. Then you know that when y is equal to 0, when y is equal to 0, one of these terms has to equal to 0 if you want to solve it. So if this term is equal to 0, then x is equal to 1. If this term is equal to 0, then x is equal to 2. And if this one, x is equal to minus 3. So you know it has to hit the x-axis at that point. And since the value in front of the x cubed will be positive, it's going to go to infinity this way. So it's going to have to go through here, come back up, go through there again, and go down. So we don't know exactly how high it's going to go or exactly what shape, but we know it's only going to cross at those 3 points. It's going to go to infinity this way and infinity that way. I'm going to do a longer, more complicated example with a 4th power to show you how to do those. 2 seconds. Well, you know, because it's a positive 4th power, it's going to go to infinity up there. That gives you the edges, but it doesn't tell you where it's going to maybe hit the x-axis, something interesting like that. Well, one way of working with that is to realize, well, what if we could factor it like this? And because this is a 4th power, we're going to have 4 factors. I'm assuming the factors are really nice. If the factors are like the square root or something, this is going to be really hard to do. But I'm assuming it's nice, which would mean one of these in front of one of the x's would have to be a 2. And here, the ones on the far side, for this to become a 3, this would have to be, there has to be a plus or minus 1 in these, or a plus or minus 3. So for example, minus 3 and minus 1 would give me this, and each of these would have to be 1s then as well. So because this is a small number, we only have a couple of options. How can we figure out which might be a solution to this, which might be a factor to it? Well, what we can do is we can plug one of these values in, because if when, let's say when x equals 1, which would mean x minus 1 is a factor, if that's a solution, then if we plug that in here, we're going to get 0 for this, because the y value is going to be equal to 0. Let's quickly do that. If this is 1, then this is 2, 3, minus 9, 1, and 3. 3, 4, 5, 6, 7, 8, 9. This adds up to 0. So x minus 1 is a solution to this. So here I've done the long division. I took x minus 1, divided it into this, and got this here. You look at this and you say, well, I've still got a 3 or a minus 3 here. So let's try plugging x equals 1 again into this. And if you do that, you're going to get a 2 plus 5 minus 7. So that's going to be equal to 0. So x minus 1 is going to factor twice. So you do that, again, long division, you're going to get something that you can relatively easily factor just by hand, and we're going to get this. I didn't do all of that. We'll do that in other videos. So here we have this all factored into this. X minus 1 squared, x plus 3, 2x plus 1. So if you figure out what the roots for that are, well, x has to equal 1, so I drew that in here. X has to equal minus 3, I drew that in here. This one, you set it equal to 0, and you get x equals minus 1, which I drew in there. So those are the 3 roots. Actually, it's 4 roots, because this is a double root. It's called a multiplicity of 2. In other words, there's 2. These each have a multiplicity of 1. So this one is twice. So we know this goes to infinity this way and this way, because it's a 4th power and it's positive. And it touches here only once and then sort of bounces off. So it touches like this and then bounces off, but it goes right through this one, comes up through that one, and goes off again. So now I'm going to do some quick sketches of exponentials and logs, and just so you know ahead of time, those are actually inverses of each other. So y is equal to 2 to the x. I use 2 here instead of 10 to the x because I want to keep my scale small. This is over here. If you plug in 0, you're going to get 1, because anything to the 0 is 1. I plug that value in there. Plug in 1, you're going to get 2. Plug in 2, you're going to get 4. And plug in a fractional value, plug in a value that's, a negative value, you're going to have to flip it over and you're going to get a fraction like that. So here I use log base 2 of x. And if you remember the definitions of logarithm, they come from this. 2, which is the base here and is the base here, to the power y is equal to x. So what the logarithm does is it finds the power. See, it finds the power that up here. So this is sort of like the definition of this, or this is another way of writing this. So what we do is we plug in some values here. 1, plug in a value of 1, we're going to get 0. So in other words, 1 here, if we want x to be 1, y has to equal 0. So that's right there. If x is 2, then y has to be equal to 1, and so on like that. So I plug those values in here, and if you have fractional values, you're going to get a negative value here because of the rules that we're going to go look at. So if you look at these and you graph these, if you forget how to graph them, if you forget how to graph logs, for example, quickly draw up an exponential with the same base 2 here, and here's base 2. Drop an exponential, and then just draw this line at 45 degrees. It's going to be reflected in that line because it's an inverse function of that. So here's the basic sine, cosine, and tangent functions. The sine is the purple, goes up to 1, comes down, and it starts at 0 there. The cosine function starts at 1, but it's shifted over. It's exactly the same as the sine function, just shifted over a little bit. So when the sine function reaches there, this goes to 0. So it just continues to rotate like that. These are both called sine functions or sinusoidal functions. The tangent function is the sine function over the cosine function. So that means it's 0 here, but when the cosine reaches 0, it's going to have to go to infinity. So it does this and then it comes down, and it will repeat itself every time like this. So basic sine, cosine, and tangent functions. Now let's look at the little bit harder ones, the rational functions. This would be a rational expression because anytime you have one polynomial over another polynomial, but if you make it equal to 0, make y equal to all of that, then it's a rational function. So in this case, a rational function is one that we can graph. So let's take a look at graphing this. What we would try to do, there's a couple of different ways. One way would be this way. We'd say, okay, there's x squareds here and x squareds here. Let's say we divide everything by x squared, which we can do if we realize that x is never going to be equal to 0. Now, if x equals 0, of course, this is an asymptote. So I can't draw it, well, I can draw it in there, maybe right beside there. But it's an asymptote straight up and down, so this will never hit x equals 0. So once we know we're not dealing with x equals 0, we can divide by x squared, and we're going to be left with 2 minus 2 over x. If x gets really big positively or negatively, this is going to basically be 0. So as things get big this way or big this way, we know they're going to approach y is equal to 2. I did this a different way here by factoring out a 2x, just like this, and realizing when you get really big, that value, x minus 1 over x, is basically going to be 1. Those are the same. So that's just another way of showing that it has an asymptote at y equals 2. So we know the line's going to get near it. We just don't know where else it's going to go. So let's just erase a couple of things here and look at this equation again. Once we've realized that we're not going to use x equals 0, then we can say, let's find out where it's going to hit the x-axis. So in other words, we're just concerned with the numerator. And we can factor out a 2x like this. We're left with x minus 1. We know we're never going to deal with x equals 0, so we can delete this. We can get rid of that. We're not dealing with that. We just have this, which means x could be equal to 1. I drew that in here when x equals 1 right there. So that's where it could hit the axis right here. And since we know it's not going to cross this line, and it's not going to cross this line, then we know it has to do something like this. And that it's probably going to do something mirror-ish over here. You could plug in 1 or 2 points just to get a general sense for it. Most of these that are something over something are going to have some sort of shape like that. Let me do one more example for you. So here we have another rational function. This one over here, just separate it here. It looks really complicated. I did this 2 different ways as well. I took an x out of the top, left with this. So here we have x over x plus 1. As x gets really big, either positively or negatively, these two will be practically identical to each other. So I can erase this, and I'm left with that equation. So when x gets really big, it's going to go to this line. I can erase this as well, 2x plus 1, which is just the equation of a straight line. Or you can do it this way, divide everything by x, and you get left with 2x plus 1 over 1 plus 1 over x. When x gets really big, this becomes just 1 in the bottom there, and we're going to be left with this. So I drew this in here. This is the equation of the straight line. So when it gets really big, it's going to approach this line. Really big negatively, and the x, it's going to approach this line. And then also we have this disallowed value at x equals minus 1. So I drew that asymptote right there. And then what else do we have? Is there any place where it might hit the x-axis? Well, take a look at this, the top here. So I'll just redo the top here, 2x squared plus x. I'll erase what I have up here. We can factor out an x, and we're left with 2x plus 1. So there's 2 different places that could hit the axis. One is x equals 0, and one is x equals minus 1/2. So I'll draw those in here. It's there, there, and there. Now we know, of course, that it's going to be approaching this line here, and it's going to be, there's going to be often a thing on the top and a thing at the bottom here. So we can sort of realize that it's going to do something like this, because it has to come through and it has to go back up. So there's really no other way you can manage this without doing something like this. And over here, this is probably going to do something very similar to that. You could plug in 2 or 3 points just to confirm where you are in this and then be able to graph it. But if you have a general sense for how these things will look, that will help you a lot as well. So I hope that video helped you. We walked through almost all the stuff you're going to need to learn about graphing really quickly in this video. If you like it, like this video, subscribe, and I'll see you in the next video. Bye-bye.